Well, there is. You can have AA, AC, CA, or CC. Those are the only ways to connect V11 and V21. Now let's look at our production lists and see if AA, CA, AC, or CC shows up anywhere. AA is there. What goes to AA? B. So B goes in this list. CA, is that there? No. AC, is that there? And CC, is that there? No. So the only way you can generate a 1-1 is through a B by generating an AA, and therefore A can generate 1, A can generate 1. Putting them together, B can generate 1-1. So at this level, at the second column, the value here depends on two values from the previous column. The value here is going to also depend on two values from the previous column. Every one of these is going to depend on two values from the previous column. What two values does this one depend on? This is 2, 2. 2, 2 looks like this. It depends on this one, which is called 2, 1, and this one, which is called 3, 1. Here the combinations are AB, CB, AC, and CC. Do any of those show up in any of our productions? AC does? AB and CB. And they give us what non-terminals go to those productions? A and C. How about here? BA, BC, CC, CA. How do you get A? Because it's BC. Can you get B? No. Can you get C? No. So just A. Next. I think we've did this.
It's just going to be full of non-terminals.
Actually, you can have empty sets here. It's possible that none of these will combine to get anything, and then you put the empty set in.
But no two non-terminals together, not BC.
No, just single sets of non-terminals, absolutely. So this is the same as what we did here. So this is going to be AC. And we haven't done this yet, BC, BC. Is there a BB? I don't think so. A BC? Yes, that goes to A. CB goes to C. AC. Okay. If you understand this so far, you're 95% of the way there. Right? It gets a little bit more involved in the next few columns, but not too bad. Are there questions so far? Yeah, Joe, you have a question? You concentrating? All right, let's go over to this one, V13. Now, unfortunately, but necessarily, we need to do a little more in this column. V13 cannot be constructed by just figuring out which non-terminals construct the left symbol and which non-terminals construct the right symbol, like we did in the second column, because now we have three symbols. So now we actually have two ways to split these three symbols up into two parts. One is that we have a single 1 followed by a 1, 0. The other is that we have a double 1 followed by a 0. Let's identify both those pairs. The single 1 is V11, and the 1, 0 is V2, 2. A double 1 is V1, 2, and the single 0 is V3, 1. We have to do the same thing we did before, but we have to consider this combination and this combination. Because any of those combined together would be able to give us 1, 1, 0. And now you can see where the exponentiation would come in if we would actually call these recursively. You get a lot of these things showing up again and again. V12 was just called before. Now we're calling it again now. We didn't want to call it and call it and call it and call itself over and over again. That's why we're working bottom up. Now let's look at these pairs, V11 and V22. That is this one and this one. And what's the next one? V12 and 31. So it goes here and here. Okay, the first one, see the beginning of my arrows? Did I do this right? V1, I wrote it wrong. V11 and V, no, it's okay. V11 and V22. And then afterwards, V12 and V31. Start here, that's your first pair. Go to the right and go down to the left in the diagonal to get your next pair. Right? Let's look at the first pair, AC and AC. This gets a little tedious, but if you look, actually we did that before, so I know you get a B. Right? Now we're going to do B and BC, which gives you no, I don't. BB and BC. So you can't get a CB. You just get just BC. You just get A, right? Right? BB doesn't appear. BC does appear after the A, so A gets put up there. Let me stop for a second. Questions about this? So we have two pairs to look at. Following this geometry, I'm going to erase this arrow for a second. If you're over here and you want to know which two pairs to look at, you can go back to the drawing board and figure it out like I did there explicitly, or you can use the geometry to help you. Start over here to the left of the empty square you're working with. That'll be the first element of your pair. Start down here diagonally, move downward, and move to the right. So that's the first pair, and that's the second pair. Let's check if that works. This would be 2, 1. And 3, 2. 2, 1 is the single symbol 1, and 3, 2 are the next two symbols over. They give you 1, 0, 1. And that's exactly what we're trying to get here. We're getting 2, 3, which is 1, 0, 1. So to figure out whether 1, 0, 1 can be accepted and by what, you go ahead and you split it into this pair and then this pair. And this is going to work all the way down. So let's actually do these. Let's finish this whole example. We're over here. Here's the first pair we do. We get AA and CA. What do we get from that? It's the B. And now we get a ACAC, which gives you just B. And we're not going to add B twice. It's a set here. So that's all we get is B. Let's go down to this one. Try to do it in your head. You start from the left and then go down diagonally to the left. So this one and this one are the first two you look at, BC and AC. What do you get from that? And I think you get something else. No, just A. You're right. Just A. And now we move to the right here and move down the diagonal here. You get AB, AC. And that's A. So just A. Finally, this one, go to the left, go down diagonally. That's the first pair. You're going to work this way and work that way. AC gives you B. BC gives you, I think, A and C. Okay, so little by little we are learning which non-terminals can generate which pieces of this string. Let's look at a particular example. This is 4, 3. That means starting from the fourth spot, 1, 2, 3, 4. The last three symbols, mainly 1, 0, 0. What non-terminals can generate 1, 0, 0? All of them can. You can start with any one of these non-terminals, and they will all generate 1, 0, 0. So that's what we learned so far. There's more work as we go to the right, but fewer entries. So it won't be too bad to finish this up.